Hello guys and welcome to another video tutorial series on searching algorithms. And today we're gonna discuss on another classical problem for technical interview which had been asked in many product-based companies like Microsoft, Amazon, Twitter and many other product-based companies. Because it not only judged the knowledge of data structure and algorithm but also judged the problem-solving ability for any candidate during interview. So the problem statement says that given an array of non-negative number which represent the height of any block, and we have to calculate the amount of water that it can hold between the blocks in a rainy day. And that's why it is more popularly known as the water trapping problem. So before going into the solution of problem, let's first understand the problem. So here the problem statement says that here we have an array of number like 0, 1, 0, 2, 1 which actually represent the height of the block in a plane land. So for example, here the first 0 means the height of this block is 0. Then comes a 1 means the height of this block is 1. Then we have again 0 means there is no block over here. Then comes 2 means the height of this block is 2. And in this way we have an array of numbers which represent the height of each block. And the problem statement says that on a particular rainy day after the rain stop, we have to calculate the amount of water that can be logged between the two pillars. So here you can see that within this two pillar we can have 1 unit of water over here. Similarly, here you can see that between these 3 blocks we can accommodate 1 block, 2 block, 3 and 4. Total 4 unit of water can get accumulated over here. So here each division is considered as 1 block of water. Similarly over here we can have 1 block of water. So on total we can accommodate 6 blocks of water over here between the blocks. So I think the problem statement is pretty clear over here. So the interviewer is asking that we need to calculate the amount of water that it can hold between the two blocks over here. Frankly telling, I am a big fan of this problem, and whenever I go for taking any technical interview, I normally ask this question to my candidates because it not only covers the programming concept but also it helps to judge the analytical skill set of the candidate. So personally, I consider this as a very important problem for any technical interview. So let's see how we can solve this problem using our whiteboard session. So here also we will be solving this problem using two approaches, one using the brute force approach and next by using the optimal solution. So let's first understand the brute force approach of how we can solve this problem. After that we will go for the optimal solution. So in this problem, if you analyze this picture very carefully, you can get an idea of how we will be solving this problem during interview. So here let's calculate one block at a time. So let's start with the first block of our program, that is block 0. So the height of this block is 0. So applying our common sense, we can easily understand that since there is no boundary on the left side of this block, so we cannot accommodate any water over here because whatever the rainwater that will accumulate over here will drain out from this side. So we cannot get any stagnant water on this region. So the water holding capacity of this block is 0. Now for the next block, if you see the height of this block is 1. Now if you see the blocks that are surrounding over here, you can see that for this block also on the left side, there is no block that is higher than this block which can help it to accommodate some water over here. So all the water that flows over here will drain out from this side. So same thing for this. So the water holding capacity of this block is also 0. Now coming to the next block, that is block number 3. So the height of this block is 0. Now for this case, you can see that this block is surrounded by 2 blocks on both sides. One block of height 1 unit, another block of height 2 unit. And the amount of water that it can accommodate over here is the minimum of the height of this 2 block, and that is 1. So it's quite clear from the picture that it can only accommodate 1 unit of water over here. Similarly for the next block over here, if you see that on the right side, we do have a block that is higher than this block. But we do not have any block on the left side that can accommodate any water between these two pillars. So it's quite clear that on the top of this block, we cannot hold any water over here. So the water holding capacity of this block is also 0. Now let's consider the next block, that is the fifth block, which have an height of 1. So over here you can see that this block is surrounded by two blocks that are higher than this block. So on the left side we have a block of height 2 and on the right side we have a block of height 3. So if you just consider this part of the program, you can see that we can accommodate 1 unit of water over here. Similarly, for here, we can accommodate 2 units of water on this region. And in this way, if we keep on iterating with each and every block present over here, we can calculate that the total amount of the water that it can accommodate is 6. So if you notice, the main concept of solving this problem is like, for calculating the water holding capacity of a particular block, what we are doing is like, first we are calculating the highest high rising block on the left side and then we are calculating the highest high rising block on the right side. So if you consider this block as our starting point, so first thing what we have to do, we have to see that what is the maximum height of the block that is present on the left side of this block. So over here you can see the maximum height of the block that is present on the left side of this block is 2. Similarly, we have to find the maximum height of the block on the right side of this block. So over here, the maximum height of the block among this subarray or the arrays of blocks is 3. And once we find out the maximum height of a block on the left side and the right side of the block, then the next step is like, we have to find the minimum of these two. So over here you can see the minimum of height 2 and height 3 is height 2. So the value of this is 2. So here you can see for this block we can accommodate 2 units of water over here, 1 and 2, minus the height of this block. So here in this case the height of this block is 0. So here we are subtracting 0 from here. So the total water holding capacity of this corresponding block is 2. Now let's take another example. Let's consider this block. So the height of this block is 1. Now step 1 is like, we have to calculate the maximum height of the block on the left side. So here if we calculate the maximum height of a block on the left side, we can see that the maximum height is 3 that is present over here. So the maximum height of the block that is present on the left side of this denoted block is 3. And then we have to find the maximum height of the block on the right side of this block. So here if you see on the right side, the maximum height of the block is 2. So we have got the two maximum on the left and the right. Now the next step is like, we have to find the mean of this 2 max over here. That is 3 and 2. And if you see that the mean of this 2 is 2. So the amount of space that we have between the two blocks is 2. Now one more thing we have to do is like, we have to subtract the height of its own block. Means we have to subtract this 1 from here. So the water holding capacity of this block becomes 1. So here we can see we can accommodate 1 unit of water over here. So I think if you just break down each and every block into a particular solution, it will be much more clearer to you. So I think it's better you take an example and just do a dry run of this logic so that you first understand how we will be solving this problem and what will be the approach to solve this problem. So I think the solution of this problem, or the way we are planning to solve this problem, is pretty simple and easy to understand. So before writing the actual code, let's first visually understand one more time using our visual display board so that it will be much more clear to remember and implement the program during interview. So let's take an example that we have an array of non-negative numbers which represent the height of a block in a plane surface. So let's visualize how we gonna solve this problem. So we will start our iteration from I equal to 0, that is from the first index of our array. And we will see the current height of the block over there. So over here you can see that the current height of the block is 0. Now the next step is like, we need to calculate the maximum height on the left side and on the right side of the respective block. So over here you can see that the maximum height of the block that is present on the left side and on the right side of this block is 0 and 3 respectively. Now to find the water holding capacity of the block, we have to find the minimum of this two max. So here if you can see, we have found out the minimum of 0 and 3, and then we are subtracting the height of this current block. So over here you can see that finally the water holding capacity of this corresponding block is 0. So once we are done with this particular block, we have to iterate forward and we have to move to our next block, that is block number 1. So again we have to do the same operation. We have to find the left max and the right max of this corresponding block. So you can see the left max is 0 and the right max is 3. Now after calculating the minimum of left max and right max, we then have to subtract the current height of this block. So here you can see that the total water holding capacity of this block is coming as -1. So if it is not greater than 0, we won't be adding it to our total capacity, and thus we will move forward to our next step. So here for the third block, you can see that the left max and the right max of this block is 1 and 3, and thus we are finding the minimum of both of them, that is 1, and then we are subtracting the current height of the block, that is 0. So the final water holding capacity of this block becomes 1, and thus we are adding that to our total capacity. And we have to keep on doing the same operation on each and every block, and we have to keep on calculating the water holding capacity, and once we are done with the entire iteration over the array, we will get the final output, that is the total capacity of water that this structure can hold after the rain stops. So here you can see that the total amount of water this entire structure can hold is 6. So I think you guys are clear with the way we are planning to solve this problem. So let's start with the implementation part of solving this problem. So let's name the method as water trapping problem. Since as a result we need to return the amount of unit of water that it can accommodate, so here we are returning the integer type over here, which represents the amount of unit of water this structure can accommodate. And here we will be passing the entire height array as our parameter. So the first thing that we have to do is we have to write a for loop by which we can iterate over this array which represents the height of the block. So let's first write the while loop. So here if you can see, we are starting our iteration from the second block over here, not the first block, because we need to calculate the height of the block that is on the left side over here. So we are just leaving the first block over here and we are starting our iteration from the second block, that is I equal to 1. So the next step is we need to find the maximum height of the block present on the left side, and then similarly we have to find the maximum height of the block present on the right hand side. So here we will call two functions that will find maximum height of the block on the left side and on the right side. So this function will return the maximum height of a block present on the left side of this block, and this function will return the maximum height of the block present on the right side of it. So here we are passing this height array over here and we are passing the current index of the block. So for the sake of understanding, let's assume that we are iterating on this block I equal to 1. And this method will return 0 from here, since the maximum height of the block on the left side is 0 and the maximum height of the block present on the right side over here is 3. The next step is we have to calculate the water holding capacity of a particular block. So what we'll do, we will find the minimum of this two height present over here. So here you can see first we have calculated the two highest point on the left side and the right side of the array, and then we are calculating the minimum out of 2, which will denote the water holding capacity of a particular block. Now the next step is like we have to subtract the height of the corresponding block that we are calculating. So here, for example, the height of this block is 1. So here we will be subtracting the height of this block. And this is the total amount of water that this block can accommodate at a particular instance. So we just need to keep sum up all the water holding capacity of each and individual block over here. So we will keep on adding the water holding capacity of the blocks. And at the very beginning we will initialize this water holding capacity of the block as 0. And thus here we will be closing our for loop. So here you can see the solution of this problem is quite simple. So what we are doing over here, we are taking each block at a time and we are calculating the maximum height of the block on the left side, and then we are calculating the maximum height of the block on the right side, and then we are finding out the minimum of those two, and we are subtracting the height of this corresponding block from the result. And we are keep on summing the total amount of water it can hold for throughout the entire structure, that is the array of numbers. So at the end of this iteration we will get the amount of water this entire structure can accommodate. So here we just need to return the amount of water it can accommodate at the end. Now the next step is very simple. We just need to implement this two function over here, that is find the maximum height of the block on the left side and on the right side. So let's start implementing that. So here we are passing the entire array and the position from which we need to calculate the height on the left side. So here we will write the for loop for iterating over the arrays of height. So here we will start our iteration from I equal to 0 till the position before that. And at the end we will return the maximum height. So here first we need to initialize the maximum height to 0. So here you can see we are starting the for loop from I equal to 0 to the position, and we are calculating the maximum height. So if the corresponding height is greater than the maximum height, then we are updating the maximum height over here. So this is a pretty simple logic of finding the maximum number from an array. Similarly, we have to write the same logic for finding the maximum height of the block on the right hand side. So here also we are passing the entire array and the index position from which we need to calculate the height of the block. And then we will start our for loop starting from I equal to position till the end of the height array. And at the end we will return the maximum value. So this is the entire program that you need to implement to solve the water trapping problem. One more condition that you need to handle over here is like, if the value of this thing is greater than 0, then we should add the resultant to our array. So you just need to write another if condition over here that if the value of this is greater than 0, then you need to add the resultant with the total amount of water. So I think you guys are clear with the solution provided over here, and I will share the entire code in the description below. So feel free to go through the code and understand the problem so that you can easily solve the problem during interview. So over here, if you calculate the complexity of the program, so here you can see the complexity is order of n, and for finding the mean and max of the number, we are using another complexity of order of n. So the total complexity of the problem becomes order of n square. So if you want the optimized solution of this problem that deals with order of n, I will share that code also in the description below. Feel free to go through that code and try to understand the solution of it. If you get any problem in understanding any of the solution, feel free to write me in the comment section below. And don't forget to like and subscribe to my channel, and if you are new to this channel, don't forget to hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's move to the next topic of our interview question. So see you on my next video. Thank you.